Hello everyone, welcome to my YouTube channel. My name is Shubham and today we will be discussing bubble sort. So let's begin. In bubble sort, we majorly sort the array in ascending order. In bubble sort, we require n iterations and each iteration we try to bubble up the maximum element toward the end of the array. In this example, I want to move this 6 to the last position. Here, then I have to move the fifth on the fourth position. So, as I said, we will require n iterations, and in each iteration, we try to bring the maximum element towards the end of the array. So let's begin the first iteration. In first iteration, 6 has to come towards the end. So we will always start from left to right. In my first iteration, I see that 2 and 4 are at their relatively correct position. Then I'll compare 4 and 5. Again, they are at the relatively correct position. I'll try to compare 5 and 1. And I see that 1 is at the greater index than 5. So I swap them. Then again, I'll try to compare 5 and 6. 5 and 6 are relatively at right position. So we do not swap them. Then I'll compare 6 and 3. 3 is at larger index. So I'm going to swap 3 and 6. Now, if you notice, 6 has reached to its correct destination. Now, again, we will try to do second iteration. Same process will start from 0th index and will go from left to right. We'll again compare 2 and 4. We'll again compare 4 and 1. Here, I notice 4 and 1 are at different index. We'll try to compare 4 and 5. Then again, we'll try to compare 5 and 3. Here, I notice 3 and 5 can be swapped. Now here, I end my second iteration. Why? Because the second largest element is at its right position. Again, we will run the third iteration one more time. Again, starting going from 0 and we'll move from left to right. We'll compare 2 and 1. We will swap 1 and 2. Then we'll again compare 2 and 4. 2 and 4 are relatively at the right position. We don't do anything. We'll compare 3 and 4. And we swap them. Now here, I terminate my third iteration because four element or the third largest element has reached to its correct position. Likewise, we'll keep on doing 6 times till all the elements are sorted. And that's when we terminate. Let's quickly see the code of this bubble sort algorithm. Here, I have created a function which takes an input array. Now I have to sort this array. As I said, in each bubble sort, we require n iterations. This n is the size of the array. Now, as I said, for each iteration, we start from the 0th index and we go till n minus I minus 1 because once the largest element has reached to its correct position, we don't do anything. Here, we'll compare array of j with array of j plus 1. If I find array of j greater than array of j plus 1, it requires to swap. So we'll be swapping array of j with array of j plus 1. We keep on doing it multiple times, in total n times. Now let's see the time and space complexity analysis. As I said, in bubble sort, we require n iterations, and in each iteration, we start from the 0th index and we go till n minus I minus 1. If you notice, this outer loop is going to run n times, and this inner loop is going to run n minus I minus 1 times. And each time it is comparing and swapping. Now in computer science, compare operations takes O of 1 time, and swapping also takes O of 1 time. In totality, we will consider both of them as O of 1 approximately. Now, if you notice, the outer loop is running n time, right? For the first iteration, the inner loop is going to run n minus 0 minus 1, which is n minus 1 times. For the second iteration, it's going to run n minus 1, that is going to be n minus 2 times. Likewise, third iteration, n minus 3 times. So it would be nothing but sum of all these n iterations. Now, if you notice, this is nothing but sum of natural numbers up to n. So this total complexity is going to be n minus 1. Now, asymptotic fashion, we consider this approximately O of n square. Now let's see some of the pros and cons. Pros of bubble sort is it is better than monkey sort. Second, easy to implement. Third one, it is actually a stable sort. Stable sort means the order of the elements are relatively same irrespective of their position that gets changed. For example, here 3 is, let's say, at 0th index, and another 3 is at, let's say, 4th index. When they'll be sorted, right, they may come together, but the relative order is still going to remain same. This 3 is from the 0th index, and this 3 is from the 4th index. Some of the cons is obviously the time complexity it takes is n square. One of the pros that I missed is it takes O of 1 space complexity. That's all. Thank you.